about let's talk about many-to-many relationships. Right? So if we think about our actors, right, if we were trying to describe the system in English to somebody, we might say a movie has many actors and an actor performs in many movies. Right? But in creating this relationship, what we end up with is not really a way of doing a many-to-many relationship this way. Right? We notice that the rating ID that we have over here, right, can only store, it's not in this diagram, because I've updated this, but it hasn't updated online. The rating ID that's here can only store one value, right? So if we put the actor ID here, that would only let us have one actor, right? Just like if we have the rating ID here, we can only have one rating. So in order to do a many-to-many relationship, we need a different idea. And this is where this idea of, some people call it a join table, some people call it a middle table, or a relationship table. What we need is something else to describe this situation. We need to expand our thinking a little bit. What you might say is that a movie has many cast members, right? And a cast member has appeared in many movies. So if we look at it this way, right? We want to try and have movies and actors related together. What we actually get in the middle is this idea of a cast member. In the case of a many-to-many relationship, we can't put foreign keys on either side of the tables. We need a third table, this join table. Right? In this table, we're going to put two foreign keys. Right? One to the left, the movies, and one to the right, the actor. Right? It goes in between the movies and the actors. Because what we want is we need a one relationship on either side. Right? This many-to-many, we can't do directly. We have to do it in the middle. So we need a name for this. We might call this a cast member. Right? A cast member relates the movie and the actor. And our diagram looks something like this. Right? A cast member is in one movie and represents one actor. What that lets us do is navigate from the movies table all the way down to many actors. Now, if we look at the movies table, we can find all of the cast members that are part of that. And then for each cast member, we can say, what actor does that represent? From the actors table, we can say, what cast members relate to that actor? And for each one of those many cast members, we can say, what's the one movie that cast member was in? Okay. We tend to have these kinds of relationships in many-to-many. Right? If we come back to your example of the Scouts, right? We have a troop and we have a leader, right? What if troops have many leaders and leaders can be in many troops? We would need a middle table, right? And we would try and come up with a name that describes that relationship, right? Maybe we would call that a troop table and a people table, and the middle would be called leadership. Yeah. Right? This person leaderships this group, troop. This troop has many leaders that are people. Same idea here. Membership tends to be a common word we use for that middle table because it's trying to relate many to many. So let's see what this looks like in code. It looks like this. Right? We're going to make another table to link movies and actors. We decide we're going to call this cast members. And you'll notice that the columns inside are named after the two tables we're relating. So it's going to store a movie ID. That's an integer that references the movie's ID. And we're also going to store an actor ID that references the actors table ID. Typically, the names of these columns relate to what we're doing here. Right? Sometimes you do see 3 columns in here, where you're joining together 3 different ideas, but 2 is the most common thing we see. Right? We need at least 2 for this idea, right, to link 2 tables, but sometimes you'll see 3.
Yeah, this table is purely storing that relationship between the other 2. So here we have our movies and our actors table. We know that movies have many actors. They actually have many castings. So in our initial diagram where we had only actors and movies, we didn't know about this third table until we started to talk about the relationship that the movie and the actors have.
Yeah. Anytime you draw out your relationship diagram and you end up with a many like this, right? A movie has many actors and actors work in many movies. You're missing a table here. You got to insert a table here to really do this linkage correctly. Right? This is why when we start to have those wireframes, these relationships start to appear. The more we can get those wireframes correctly, the more we can sit down and look at them and start describing the relationships of the data. Right? This is why we drive from wireframes to HTML before we even start talking about databases, because often the way we try to represent data will reveal these relationships in a nice way. We don't have to try and guess at what these relationships are. Our user interface will often tell us. So if this is the table that links movies and actors together, let's assign some actors, right? We're going to make Orlando Bloom for Pirates and Lord of the Rings. So we need to know the 3 Lord of the Rings movie, and we need to know what the Pirates of Caribbean movie. And this is where I think I screwed up because I deleted movie number 2. So ignore this for a second. I'm going to recreate my, oh shoot. I'm going to do a different query, this one here. It's 15. It was 2, but now it's 15 because I deleted Pirates and I reinserted it. So when I say 2 here, I mean, when I say 15 here, I mean 2. Right? So if we're going to relate Orlando Bloom to the Pirates movie and Lord of the Rings, the 3 Lord of the Rings movies, are 9, 8, 9, and now 7. Oh, there it is. Right? And the Pirates movie is now 15. So to relate Orlando Bloom, who's ID 1 in our actors table, yep, there he is. He's ID 1. We need to create cast memberships. So we're going to insert into cast members, giving it a movie ID and an actor ID, where the movie is 15, and the actor is 1. That's going to associate movie 2/15 with Orlando Bloom. And I mean to say 15 here. Right, and then these are going to relate him to the 3 Lord of the Rings movies. 7, 8, and 9. So if I look at my cast memberships, I have 4 cast memberships relating 1 actor to 4 movies. Let's put Warwick Davis in Harry Potter and Hitchhikers. Update Warwick Davis for Harry Potter. Harry Potter's movie ID is 3 and Warwick's actor ID is 2. Oh, we don't put him in. That's interesting. We're missing something there. Right. So Warwick Davis is ID number 2 actor. Here's Warwick Davis. And the movies, right, ID number 3, right, is Harry Potter. So this puts Harry Potter movie to Warwick Davis, the actor. And so we should have put him in Hitchhikers as well. right? We find Martin Freeman, whose actor ID is 3, and The Hobbit, right, 4, 5, and 6. And finally, Hitchhikers, which is movie 10. So we'll put all these in. I wonder why the formatting of these is also weird. Something's weird in the formatting. So now we want to query casts and actors. In order to tie movies to actors, we first need to join to cast members. It's in the middle. And then we're going to join cast members to actors. Right? Since cast members table has relations to each of these tables, it's the link in the chain between the two. So now we're going to pull the movie's title and the actor's full name from the movies. That's where we're going to start. We're going to left join from movies to cast members by relating the cast member's movie ID to the movie's ID. Right? If we name our columns very nicely, these things kind of link up, right? See how movie ID is here on cast members, and we have movies ID here? That pattern helps us figure out what the linkage is between these tables. Once we've joined from movies to cast members, right, we've come from here down to here. Now we need to go from cast members over to actors. So once we've done that, we're going to left join cast members onto actors by saying the actor's ID has to match the cast member's actor ID. This is using the cast members in the middle to pull this. Okay. Pirates of the Caribbean has Orlando Bloom in these movies. Warwick is in this movie. Martin Freeman appeared in all of these movies and Hitchhikers. We started from movies. We joined movies to cast members, and from cast members to actors. Thus, we can get something from the actors table right next to something from the movies table by joining through.
And the Hitchhikers, would the Hitchhikers be listed twice?
It would. Let's do that, because we meant to do that.
I believe that's actually next.
Is it?
I know that's something that we do.
No, we missed it. So let's insert Warwick into Hitchhikers. So what's the ID for the Hitchhikers movie? It's 10. And what's Warwick's? He's 3. He's 2, thank you. Let's insert into cast members the movie ID and the actor ID. The values, what's the movie ID? 10, and Warwick is 2. Okay. We're going to insert into cast members some movie and actor relationship. It's movie number 10 and actor number 2. And if we repeat this query now, Hitchhikers appears twice. Okay. Hitchhiker's Guide to the Galaxy had Martin Freeman, and Hitchhiker's Guide to the Galaxy also had Warwick. Okay. The movie appears twice because it's in the cast members table twice with 2 different actors. Right? Just like we have Martin Freeman and Warwick and Orlando in multiple movies, we can have multiple movies having multiple actors. This is a many-to-many relationship, and it always involves that middle table.
So let's say we're doing the Parent Trap. Would you have 2 Lindsay Lohans?
Yes, because yes.
How do they do the quiz?
Good question. What else could we put in the cast member that's missing from here?
The role.
The role. The role that's a super good question. I'm going to steal that for next lecture. Right?
That's going in the notes.
That's going in the notes, because that is not an attribute of the actor. It's also not an attribute of the movie. It's the attribute of the role, the cast member in the middle. So that middle table can get more information if it has to do with the 2 things together. That movie and that actor played a role. So in that case, Lindsay Lohan would be listed twice in the cast members table. Once as the mom and the, no, she was twins.
Twins. Yeah, she played both kids.
Right, and it was like confusing the parents or something. I don't
Yeah.
remember the movie. Yeah,
Vicky
so she
Friday
would.
was the one she played.
Right.
Where she's the mom and
Is the mom? Yeah.
Originally it was Patty too.
Ah, right. So that she would be listed twice in there with two different names of the roles. Yeah.
So on a similar note, Orlando Bloom plays the same role in several movies. He's Legolas in Lord of the Rings and The Hobbit.
Mhm.
So would that be like, so both of those would show up multiple times?
Yes. Yes. So if that's a thing and you wanted to track a role across multiple movies, that would be a third table we would join. So that maybe we would have a third table called a role, right, that has an ID and a title, and that would be joined to cast membership as well. Because you would want to know what movies did Legolas appear in. That's or a character table. Maybe we call that characters. So that character table, maybe it's hanging out down here, is also linked to cast membership. So Orlando Bloom played Legolas in that movie, and there would be 3 IDs here. That would be a 3-table middle join, right, relating 3 different entities together. See how like we can take the same idea and keep making it more complex based on how complex our data is. I'd love to see the ERD for IMDb.
Yeah.
I wonder if that's available, because I'm sure it's super complex.
Yeah, it sounds really organized, but also really neat at the same time.
Yeah. Yeah. The more relationship heavy your data is, and the more ways you want to query it, it just means that our diagram and our table structure just gets more complex. And those joins start to get more complex. The nice thing is when we get into C# and Ruby, they have ways of simplifying that work. So we don't necessarily have to worry about all of those complex joins. That's the nice part of where we're going to go next after we learn some C# and Ruby, is the idea of an object relational mapping tool where the code is going to generate these super complex joins for us automatically, right? Because having like a 3-table left outer join is like, right? So we don't want to work at that level of complexity. We want to describe our data even more generally and let that general tool write those difficult queries, right? And that's the positive part that layering code on top of this helps with. But as developers, we still need to know what's going on, right? Because at some point, your boss or your senior dev is gonna be like, hey, this data is too complex for our ORM. I need you to write this SQL query, one-off thing. Yes, I remember how to write SQL queries directly. I can still do that. And you'll notice that as you start working in Rails for the Ruby students or .NET, you'll see the framework, the code, writing queries for you. And you'll see those queries kind of like how when you have Yarn, that screen that's running your Yarn server, and you see warnings. You'll see that, and you'll see all of the queries that Ruby is writing for you and all the queries that .NET is writing for you, or C# is writing for you. It's good for you to know, oh yeah, I expected a left outer join here, or I expected to see a where clause that said ID equals 75, right? So since SQL is kind of the language of the database, we still need to learn it. But fortunately, the next thing we're going to do is layer some code on top of it to make this easier for us.
In the code is one of the ones this morning. We're writing in SQL, and then it asks if you can refactor it if you want. Is that what you're saying we're going to get into when we get into our link separately?
A little bit. Refactoring here, what they mean is if your code is not as efficient, or if there's a shorter way of writing it or a different way of writing it, that's what they're still staying in SQL.
Okay.
Here, what we're doing is, so you remember you all, like in week 2, where you're writing like query selector all, add event listener, delete the things from the DOM and redraw it. And like, oh, this is so tedious. And they're like, hey, let's not do that anymore. Let's do React. Because React is kind of a higher level idea that removes all that drudgery from us of like query selectors and add event listeners. Maybe you think it replaces it with different drudgery, right? State and props and right components, but it lets us work at a higher level of what we call abstraction, away from the nitty-gritty details, right? Which is why we teach you the details first and then the abstraction. The same thing is coming for SQL. So we're gonna do SQL today and tomorrow, but starting probably Monday of next week when we get into, once we get past like, hey, let's teach ourselves some Ruby and some C#, we're going to be writing Ruby code that sounds a lot like the terms that we used here, but we're going to be writing Ruby, and that Ruby is going to generate the queries for us. We're going to be writing C#.
That side is the same thing. If you recall from our C# versus Ruby last week, the numerals in .NET, .select, .where, .distinct, .sum, stuff like that, .order by, sound a lot like SQL terms. Because the enumerations in C# has a very SQL-esque background.
Yeah. So you'll be talking more C# than you will SQL, but you'll see in the background that C# code is generating those for you. Where that plays really nicely is when our data model gets really complex, the SQL gets complex at the same speed, but the C# does not, and the Ruby does not. It lets us keep going with complexity easier when we're in code than we are straight in SQL, right? So as our data model gets more complex, the SQL rises to meet it, but the language part lets us delay that complexity because we're talking about it in more abstract ideas, and it's worrying about, oh shoot, this is a 6-table join. I know how to do that, even though you don't, right? You're describing it like, oh yeah, movies have many cast members, and cast members have many actors. And by the way, there's tables with all those things, and the system's like, cool, I know how to join all those things together. That's all you need to tell me, right? And it writes all the joins.
So that's what it's called, joins. It's not called mapping or spidering or anything like that. You just call it joins.
Yes, because literally we're taking the 2 things and we're joining them together, right? Or we're taking the 3 things and we're joining them together. And those IDs on either side, right? I don't have a diagram that has it yet because it hasn't updated.
I didn't know if there was like a meta term for it.
No, we just call them joins or relationships. There's not a diagram in here that has it. Right, it's these relationships. It's the cast member's movie ID. That's the linkage to the movie's ID. Right, so that's why having that unique ID is so helpful. The fact that the system generates it, it gives us a natural thing on both tables to link up. Right, and we'll see how even when we start to get to Ruby and C#, Rails and .NET, we primarily don't even deal with the IDs either, right? That kind of just also happens for us magically, right? So we're learning the details, and then we're going to kind of push them away a little bit.
So say for example you want to add like a review table,
Mm-hmm.
and you have like people who's actually seen the movie and you want to write a review and such.
Mm-hmm.
How does that? Do we basically do the same thing where we incorporate a line, link it with your cast members, and okay?
Yep, we would have somewhere we'd have a big piece of paper. Go into most dev shops somewhere they have a big ERD. If the app is of any size, maybe it's in a PDF, maybe it's on a board, and you're like, okay, well I need to add a review. What are the elements of a review? Well, who did the review? What movie were they reviewing? Maybe how many stars they gave it, and maybe some text. So I would then look at that review and say, well, the review has one movie, right? This review is about one movie, right? And this review is from one user. Can a movie have many reviews? Yep. Can a user make many reviews? Yep. I would draw all those lines and, right, ones and many's. And then from that, I should be able to start making my table. Create table review has an ID. It should have a movie ID, which movie are we talking about? It should have a user ID, because it has one user. It has some number of stars, as an integer maybe. And it has the body of the review as text. There we go. That's how I've related all of those things. So as you start working through your capstones, you should start to think about what are those big squares in my entity diagram? What are the things that go in them? And what lines connect to those boxes, right? A blah has many blahs, or belongs to one blah, right? A's and B's, movies and ratings, right? Movies and actors. Oop, this is a many-to-many. I need a middle. And you'll go through that process a couple times. You'll review that with Mark and I before we start doing anything. And once you have that entity diagram pretty close, you'll start making your database, right? And we actually probably won't even do the create table stuff because both .NET and Rails gives us another way of managing our database. So after tomorrow, that's probably one of the last times you'll be using PGCLI in this class.
Yeah.
Because we're going to find new tools that allow us to talk about our data even closer to our ideas of it and further away from the guts of SQL.
PGCLI comes more into the category of the web Chrome dev tools, or it's just something to help us see kind of what's going on inside of our app. Is everyone actually using PGCLI directly? So it kind of goes into a developer toolkit, not so much a end user experience.
Yeah. Cool. So these are mostly the types of relationships that we see, right? One-to-manys, like our movie and our ratings, and many-to-many, typically 2, but sometimes 3, if we want to put in role and or character, right? That might be a 3-table middle table. But I would say most of the time, the vast majority are 2-table many-to-manys, right? That and remembering the different kinds of joins are mostly what we need to know about relationships and databases at this point. That will get you through probably every one of your capstone projects. These kinds of diagram relationships and remembering these kinds of joins. Does it get more complex? It sure does, right?
Yep.
But for the types of things we're doing, we're probably not going to get there.
Yeah, so for a majority of your capstones, you might have at most half a dozen tables, maybe.
Yeah.
For real production, like production app, whenever you get that first job and see the first ERD, it's going to be this big in PDF with 8-point font with about 100 or so boxes of each one you get from the database table. It's going to be a little bit overwhelming. But
Yeah.
Even no matter how big that ERD gets, it's all down to each box is a table and each line is just a relationship. And that's it. It's these basic fundamental building blocks of like, what is SQL and how does the database work?
I'm trying to see the app that I worked on before I worked here. Had 96 different tables in it, with probably as many joins in between, right? And that's not uncommon for a decent sized system to have 100 or more tables.
Oh yeah. Of the couple handful apps that I worked on before I was here, my main one had about a dozen different collections. It's a different type of database system, but pretty much a dozen or so tables. And the other one, it interacted with an insurance API, which had about 50 some tables, to say the least. Each table had a couple hundred columns on it. So yeah, it's a different kind of scale, but that's nothing you need to be concerned with.
Yeah, but the same idea still work,
Yep.
right? I think the most complex join we had was like a 3 or 4 table join, but I would say
Yeah.
85 out of those 96 tables were only ever involved in a 2-table join, right? So these ideas scale all the way up to big systems.
And you're
Right.
never going to be dealing with like every single table at once, which is like
You shouldn't be. You
Yeah.
shouldn't be. Yeah. If you are, typically that's a sign of a bad design. You might need to refactor your ERD to be a little bit something a bit more useful.
Yeah.
Or, easy to query.
Yeah. So when we talked about finding those big squares, right, of the system, it's a balance, right? So making sure we have the right entities in that model, right? Movies, ratings, actors, right? In systems that have too many tables, they've over-normalized. They've extracted too many entities, right? And in order to put everything back together, you've got to join a whole bunch of tables to get the information back, right? In systems where you have a small number of tables but a huge number of columns, that's probably under-normalized. You could probably look at some of those columns and say, gee, these 12 columns, they kind of belong together. We should pull those columns out into a different table, right? And have, you want not so wide tables, but not also a huge number of tables. It's balancing those two. And that's where like a data administrator or a database designer comes in and says, hey everybody, we need to change this design. We need to pull some of these tables out or merge some of these tables together, right? That's where your performance team comes in, right? The role is sometimes called like a site reliability engineer. You heard like SREs. I found out that Uber has 100 people on their team that are just site reliable engineers. 100 people that work at Uber just to make sure that the app and the API is working. That's their only responsibility, is to keep. So when you say like request car, right, they want that API response to come back really fast. 100 people just on that team, right? And that team is monitoring how long did the API call, how many SQL queries were executed, how long did they take, how many tables were hit, how many rows did they look at, how long did the database take to return blah, 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 blah. And they come back and tell the developer teams like, hey, this table's too wide. This table has too many rows. We need to renormalize and move some of the data around so that our API can be faster, right? So depending on the size of the team you have, different people are looking at those kinds of aspects of what that ERD looks like, right? And they have tools that tell them those kinds of performance numbers.
So what kind of ID base do they have?
How do they track their data? I don't know. Most companies keep that really, 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 really internal. They usually don't like to talk about how big their database is, how many database servers they run. I know the last time I heard Facebook runs something like 30,000 database servers, something like that. Just database servers, right? How many tables and structures they have, I don't know. But I heard a number like 30,000 just database servers, which is enormous, right? Most companies run one.
Yeah.
Yeah, they're a little exceptional.
Yeah, they're a little exceptional, right? But a lot of companies don't like to talk about what their relationship diagram looks like, or how many rows their tables have, or how they structure things, because they kind of consider that their proprietary intellectual property. So I was always curious when I hear people talk about those kinds of things, because I find it kind of neat. I might look into whether IMDb has that public or had it public, because it was
Maybe not have a public.
because it was an independent project at one point,
Yeah.
before it got bought by Amazon, I think.
No.
Yeah, somebody bought IMDb. I think it's Amazon, right? Maybe I'll see if I can find some examples of some ERDs for popular apps.
Yeah, there's a lot of ERDs for movie apps that are generic, but not like IMDb specific.
Yeah.
Because apparently they store it in a flat structure, not a relationship structure,
Ah, okay.
and then more a tab-based column layout.
Ah, okay. Yeah, I'll do a Google search and see if I can find for some like decently popular apps, like what their database structure might look like, because I think that might be interesting for you all to see. Cool.
So is there anything specifically that makes them more vulnerable? Is the database more vulnerable than others? Like,
Not so much the database, but the way we access the database. So when we get into C# and Ruby, we'll talk about kind of the security aspect of how do we talk to the database, because most of the vulnerabilities that have to do with databases don't come from the database or the design of the data. It usually comes from how we access the data. And primarily, how do we, right, I talked about the code in the middle is the link between the user and the data, right? We have to be very suspicious of users, even if we think all of our users are nice. Not every one of them are, so we have to be very pessimistic about what the user sends us before we take that and use it to fetch the information in the database. That's where most database vulnerabilities come in, with that code in the middle, right? Which is mostly what we write, right? So we have to be conscious of that. And both .NET and Ruby and the Rails framework have done great work to make that easier on the developer, make it less likely that a developer is going to make a security mistake.
They handle a lot of the common use cases for security attacks, which is awesome, which is why you should use stuff like ORMs and the frameworks. Some people don't use ORMs for a variety of reasons, speed, complexity of data model, there's a whole bunch of stuff there. But if you use like libraries and stuff like that, they usually have stuff baked into at least for prevent the basic stuff, like cross-scripting.
Yeah.
I wonder, can we use Excel as a database?
Excel can be like a database, and a lot of people have written database systems in Excel. because Excel has a lot of the types of things that you can do with a database. They quickly get out of hand. I mean, I've seen people implement all kinds of weird, wonderful, zany things in Excel because it has some of the same things. It has lookups and it has joins and all of those things. But at a particular scale, it's worse to do it in that than it is to do it in a real database, right? I'm keeping my wedding invitation thing in Excel because it's got 100 rows and it's easy. And if I then have like an RSVP tab, I might write a quick lookup between the RSVPs and the invitees and make a little thing. But that's about the level that I'm going to stop working in Excel. Like as soon as it gets more complicated than that, I'm going to make a little database. Right? So like a couple of little tables that you look up things in, awesome. Excel's really, really good at that. But at that point, you got to stop and turn things into a database.
Couldn't you upload the data that you and you put it into Excel to the database?
Absolutely. Yep. And there are some libraries that let you treat an Excel spreadsheet as if it were a database and pull things out of it. So I've seen a lot of people make money just going into companies and taking their weird Excel spreadsheets that people in HR have written in the accounting department and turn those into web apps, right? Because that's where a lot of internal apps start as, because, you know, Bill has got an Excel thing that he's been collecting how he does his inventory for years. And then all of a sudden it gets so complex that he can't do it anymore, or Bill leaves and no one knows how it works. Somebody comes in and takes what he built and turns it into an internal app. A lot of internal apps start out as somebody's weird Excel idea to keep track of something. So yes,
I'm pretty
you could
sure
use
that
Excel like this.
Excel can do like math between like columns and stuff.
Oh, yeah.
So SQL can do that too, right?
Mhm.
Okay.
Yep. Yeah, I mean we can do math right on.
It's not just for like storing and delivering
Right.
data. It can also
Yeah.
be used to like
You can do entire business logic in SQL. It's not uncommon to have what's called stored procedures, which are pretty much like functions inside of SQL that actually do like your business logic for you.
I mean, if we wanted to ask, what's the average year for movies to be released, right? We can select average year released from movies, right? On average, movies were released in 2003, right? Or what if we wanted to know how many movies were released per year? So we could select the year. We could select the year released and the count of how many movies that was from the movies table, grouped by year released. There were 2 movies released in 2003. There were 3 movies released in 2005.
so it counts like a built-in thing.
Yes.
Nice.
Yep. If we group all this information by the year released, I want to know what was the year released and how many were released in that year. Right? What if we change this to genre? And we change this to genre. Aha. That's weird. Why did we get... Oh, because one has a capital F. Sci-fi. Sci-fi, capital Phi, sci-fi, little phi. Yeah. So there's really 2 sci-fi movies, 9 fantasy movies, and 3 horror movies. Right? So the database has a lot of power in it. What's nice is our tools that we're going to learn allow us to use a lot of this power for our purposes. Yeah. Like I said, SQL is a pretty complete language, and you can do super amazing things in it.
Yeah, I've seen really awesome things with it, like for loops and stuff,
Mhm.
implemented in like temporary tables, creating temporary flags,
Yeah.
creating those temporary tables. Really awesome, really dumb stuff too.
Yeah.
But really awesome stuff as well.
Yeah. Yeah. Primarily what we're going to use it for is just a way to create, read, update, and delete data. But since it's a full SQL, most SQL implementations are full programming languages. You can do everything you can do in JavaScript in SQL if you so wanted to. Don't know I'd recommend it, but you can do it, right? Because it's a language geared towards querying data, which makes its ability to do other things a little weird. But as long as you're just manipulating and counting and averaging and computing data, oh, it's wonderful, right? Because we could probably do this in JavaScript, right, with some kind of like weird map and filter and reduce. But I like select genre, count star for movies group by genre. I can even kind of read that and guess what it might do without even kind of knowing a lot of SQL language. That's what's nice about it. Cool. Let's talk quickly about what tonight's homework is. We're going to expand our company database that we did last night to have departments, products, and orders. We're going to work with foreign keys. We're going to build queries. We're going to delay the final project stuff because usually this is on Thursday, but we flipped the script this week. So you're going to add some tables called department. You're going to come up with a few columns for it, what you think is appropriate to keep track of in a department in a company. You're going to add a foreign key in your employee table to link to that department. So that way your employees can belong to departments. We're going to add products and orders. That's weird, there's a wrong tick there. Right? So we can keep track of products that the company has and orders that have been made. Right? In our company, an order can have many products, and one product can have many orders. Right? This is going to be a many-to-many relationship. Create the tables and foreign keys needed to make this happen. And then build up some queries. Right? Give it a department ID, give me all the employees. Give it a department name, give me all the phone extensions, so forth and so on. Right? And then like we did before, turn in the queries as a GIST. So this is like yesterday's homework, but now adding some more tables and working on relationships between them. Cool, so you can reuse the database you did yesterday and just start adding these tables and these relationships in. Cool? How are we feeling? Good. Did we burst the bubble of how wonderful SQL is from day one too badly on day two? Did that pattern continue? Hopefully not too bad, right? Joins are more complex than what we did, right? But once you get past the first few, the pattern is there and you can kind of follow that same style, right? It's very self-replicating, right? Once you kind of get the idea of one type of one-to-many join and one type of many-to-many join, they're all kind of the same, following that same pattern.
And really how I look at it is that a many-to-many join is just two one-to-many joins with an extra little table stuck in there.
Yeah.
And like that's pretty much it.
Yeah. Yeah.
Just representing a bigger idea.
Cool. All right. I will put homework out.